In Module 4, Lesson 27, well, it's titled The Nature of Solutions of a System of Linear Equations. Fancy words for basically what type of solutions can we get when we solve a system. We can obviously get one solution if we're graphing where the lines intersect. And as we worked on the last lesson, we can have no solution because the lines are parallel and they're never going to intersect. There is no x and y value that makes both equations true. And then the third thing that's going to come into play here is what if every single pairing of x and y values that makes one equation true makes the other one true? Then we'd say there's infinitely many solutions. So those are the three types we're going to be working on. And in fact, let's write that down. Okay, so we have one solution, we have no solutions, no solution, or we have infinitely many. That's going to be our three options, okay? And the way we're going to see that is by putting them in slope-intercept form, because again, it's all going to base on that slope, and then we go to the y-intercept. So let's start there. Determine the nature of the solution. So it's not saying solve, it's saying determine the nature. Is it one solution, no solution, infinitely many? Determine the nature of the solution to each system of linear equations. Now, the cool thing with this, first thing I do is I look at it and say, hey, this is already in slope-intercept form. Don't need to worry about changing that one into slope-intercept form. But this one I need to work on. So 3x plus 4y equals 5. And again, guys, when I'm talking about slope-intercept form, I'm talking about this. Y equals mx plus b. Whatever's being added on is our y-intercept. Whatever our coefficient x is our slope. Okay, that slope is telling us what the line's doing. Y-intercept is telling us where it's hitting the y-axis. All right, so solve for y. If I'm solving for 4y right here, I need to get rid of the 3x. It's positive 3x, so I combine it with the negative 3x. Whatever I do to one side of the equal sign, I do to the other. I'm going to sound like a broken record. You guys are going to keep hearing me say that over and over. These cancel because it adds to 0. I bring down my 4y equals 5 plus a negative 3x. You could write that as 5 minus 3x. Don't combine them, though. They're not like terms. I like to leave it as addition, though. Okay, now this is 4 times y, and I want just y, so I'm going to divide both sides by 4. Remember, when I divide the right by 4, I'm dividing everything by 4. Do not stress that you get this like 5/4 here. If you wanted to write that, I think it divides to 1.25, you can, okay? I would leave this slope here, this negative 3/4 though, as a fraction. Okay, if you want to put it in parentheses there, just because we have a rise or a run. So now, check out your slope, okay? Negative 3/4. Remember the slope, whether it comes first or second, is always the coefficient, the number attached to the x. They're the same. So we have same slopes. If the slopes are the same, then you go to your y-intercept. Plus 1 plus 5/4. Again, it doesn't matter what order it is, because adding we can change the order around. Are those the same or different? Different. They're different y-intercepts. So, as we learned in our last lesson, if you have the same slope but different y-intercepts, that means you have two parallel lines. So there is no solution. Okay? This is what we're going to be doing over and over and over again, okay? So let's look at the next example. Unfortunately, neither of these is written in y-intercept form. So we're going to have to do both, change them both into y-intercept form. Yay! But at least you get a lot of practice. When we practice things, we get better at it. Excuse me. So, solving for y here, I have to get rid of the 7x. Whatever I do to one side, I'm going to do the other. And again, I'm not combining negative 4 with a negative 7x. They're not like terms. If this had x's, I would, or if this didn't have an x, I would, but I can't. That cancels out. I'm left with 2 times y equals negative 4 plus a negative 7x. Look familiar? Like we've done this a few times? Yeah, because now I'm going to divide by 2. This is multiplying. We undo multiplying by dividing. So I'm going to divide everything by 2. and I'm going to get y equals negative 4 divided by a negative 2 is a negative 2. Plus, again, I'm just going to leave, I mean, you could change it to a decimal, but I'm just going to leave this as a negative 7 over 2 times x. Okay, I'm just kind of pulling these out together so I can see my slope. All right, let's do the next one. X plus a negative y. Notice how I kind of caught myself there. Instead of saying x minus y, I'm going to say x plus a negative y. And then I'm going to put a 1 in there. Put a 1 for both, just to kind of help me out. Equals 5. Now, I'm solving for y, so I have to get rid of the x. So I'm going to subtract x, or subtract 1x if you want to think of it that way. Those are opposites. They give us 0. So I have negative 1x equals 5 plus negative 1x. Divide everything by negative 1. And I get y equals 5 divided by negative 1 is a negative 5 plus negative divided by a negative is a positive 1x. Now, start with your slopes. The slope is the number attached to the x. I have negative 7 over 2 and I have 1. To me, those are different slopes. As soon as you have different slopes, there's one solution. Okay, it doesn't even matter what the y-intercepts are. Different slopes means one solution, not one solutions. That I tried to write. Okay, we probably can guess what this last one is. We have no solution, one solution, but let's just do it anyway so we can see what infinitely many solutions look like. Again, neither of these are in slope-intercept form, so guess what? We're going to practice again. And guys, if this seems overwhelming and confusing, stick with it because we're doing the same thing over and over and over and over again, okay? Just keep listening, keep practicing. 9x, oh, I want to do this in blue. Why? I don't know, but 9 times x plus 6 times y equals 3. Okay. Solving for y, let's get rid of the 9x by subtracting 9x from each side. 9x minus 9x is 0. I'm left with 6y equals 3 plus a negative 9x. Divide by 6, divide by 6, divide by 6. Y equals 3 over 6. I can reduce that to a half. Okay, it's always good to reduce because sometimes our slopes might look different, but they actually are the same thing because they reduce to the same fraction. I can divide both of these by 3. So 9 divided by 3 is 3. So negative 3. 6 divided by 3 is 2. So negative 3 over 2 times x. All right, let's do this one. 3 times x plus 2 times y equals 1. Solving for y, I'm going to get rid of 3x by subtracting 3x from each side. 2y equals 1 plus a negative 3x. And divide everything by 2. 2 divided by 2 is 1y. Well, that's a half, 1 over 2. Plus, oh, looky here, negative 3 over 2 times x. So, look at our slopes. Same slope. Look at our y-intercepts. Same y-intercepts. So if it has the same slope and same y-intercepts, even though they look different, okay, they actually represent the same line. We did that quite a few lessons ago. But we're going to say that this has infinitely many solutions. Okay, so this is what we're focusing on right now. I know my hand hurts from writing so much, so we're going to do one more thing and then we'll stop. But identify the slope. If it's the same slope, you have two choices: infinitely many or no solution. So then you look at the y-intercepts. Okay, different slopes though, it's going to automatically mean one solution. So let's just sum that up right here. Okay. All right, one solution. And I'm going to cheat a little bit. Okay. One solution. Okay. When we say there's one solution, we say that there's an intersection point. Now, an intersection point means if we graph the lines, they're going to intersect at some point. Okay. And that also means that they have different slopes. Okay? So if there's one solution, that means that the graph means there's an intersection point, they cross somewhere, they have different slopes. Another thing we have here I'll use this color. Okay, we could also have no solution. Okay, and if we have no solution, that means the lines are parallel. And that also means, lots of information here, they have the same slopes, but different y-intercepts. So one solution, no solutions on the graph. One solution, they cross. There's no solutions, they're parallel. Different slopes, one solution. But same slope though, we have a couple choices. Oops. We'll try this now. We also could have infinitely many solutions. That means they're the same line, defined by the same line. They're also going to have the same slope, not the same as, that I keep trying to write, same slope, but they're also going to have the same y-intercept. Okay, same slope, same y-intercepts. All right, so those are our three choices for the nature of solutions. It's been a lot of writing, but I hope what it actually does is it makes the problems a little bit easier for you. Instead of going through all that work, you can probably tell if it's worth solving the equation if you know there's going to be a solution.